Hello everyone, it's nice to meet you today and we'll follow the topic with TAP system. Thank you for your responses in relation to the last webinar. We met some new issues, new questions, and that's why we want to continue with the topic. Today we'll be focused on TAP 03.02. Which one is related to the crankshaft position sensor holotronic version. We have the car, and the car is Honda Accord with 2-liter engine, and it's equipped with the CNG system. That's why TAP is also important in this matter. So as last one, we start from explanation about the genesis of the TAP is existing in the system and why, and the main reason of this. That's why, as a reminder, we once again present you the two graphs and explain you some briefly information in relation to TAP. So as you can see on the left side, it's just the graph in relation to the piston position in the ignition chamber. On the right side there is a graph when we have a pressure and the position, angle position of the piston and the crankshaft. And the main thing important in relation to the pressure in the cylinder, as you can see, after the ignition position, like the letter E indicates the start of burning the mixture in the chamber. Then you can see how the pressure is rising up in the cylinder, and the position of the maximum pressure is around 10 to 12 degrees after TDC, and this is in relation when the engine is constructed to work with the petrol. In situation when we have alternative fuel, if we start burning on the same ignition angle, the pressure rise up in a different way, and the main reason of that is that they are chemically different, and the timing of burning the petrol is much more shorter comparing to turning the CNG or LPG in the cylinder. That's why we are having additional 10 to 15 degrees of pressure rising up, so the timings is around 100 to even 200 microseconds difference, and this difference generates the end efficiency of the engine is a little bit lower. The torque and the power output is sufficient lower, even 15 to 20%. That's why we need to manage and change the default ignition angle comparing to the petrol ignition angle. We need to advance it. In case of LPG, it's around 5 to 7 degrees. In case of CNG, it should be done even in values like 15 to 20 degrees. Comparing to default ignition angle, it should be 7. In case of CNG, even 15 to 20 degrees. And that's the reason that why we need to manage adding to the full conversion kit additional TAP unit.
That's right. That's right. And after the connection of the TAP, we can change the time of the ignition by changing the values from the camshaft and crankshaft position sensor. Right now we have a car connected with oscilloscope, external oscilloscope, and we would like to present you the proper wires, signals from the proper wires, how to find the proper wire, how to connect TAP, and then how to calibrate this device.
Exactly, and this car is equipped with 3 holotronic sensors. The crankshaft sensor is a holotronic one, and there is existing also 2 camshaft sensors. One is an inlet, and second in the exhaust camshaft. That's why we'll present how they look like on the oscilloscope, how the system recognizes the signals, and if everything's work fine after autocalibration, we will show you the main settings in relation to the advancing the ignition, yes, so on. So we'll start the engine and follow the next steps.
So right now the engine is working, and we have just connected the oscilloscope to the camshaft position sensors. As you can see on the left side we have the camshaft position sensor on the inlet, and on the right side we have the camshaft position sensor on the exhaust side of the engine. So the blue probe is connected to the camshaft position sensor on the left, and the yellow to the camshaft position on the right.
Yeah, and then the crankshaft sensor in this engine is located at the rear end, and we have very tough access to it. That's why you can see here we are connected with the probe sensor to the directly in the TAP socket. That's why we have the probe connected here, and we'll read the signals later from the crankshaft directly from TAP unit.
Okay, so now.
So yes, let's share the screen, please.
And now we have the signal on the oscilloscope, external oscilloscope. Here you have the two graphics. One is the camshaft position sensor on the inlet and on the exhaust side. As you can see on the blue probe and the yellow probe, we have typical halotron signal already gathered. So right now we have information about the camshaft position sensors. What we want to do right now is to connect the crankshaft position sensor.
I will switch the yellow probe to the crankshaft. Let's do it.
Okay, Marcin will change it.
Yes,
okay.
And then you can check it.
Okay, so right now on the blue left, we left blue probe on the camshaft position sensor, but the yellow probe right now is connected to the crankshaft position sensor. As you can see, the signal from the crankshaft position sensor is also typical halotron effect signal. That means in this particular case you need to use tab 0302 to connect to this Honda engine.
Exactly. That if you're gonna use the scheme and connect it properly, we can follow on, turn on the application. We can, of course, follow the settings. And Thomas just want to say something more about the manual that you can see now on the screen.
Yes. Just to remind you that from our AC STAG software, when you choose help and then documentation, you have access to all the manuals that you want to use. It's manuals for our gas controller, but also for the TAP controller. So if you go to TAP controller manual, right now we have the STAG TAP 032 wiring diagram, and as you can see on the left side there is information how to check the proper signal in the crankshaft position sensor. The same we can do step by step the same things when we want to check the signal from the camshaft position sensor. As you can see, we have the ground, the power supply is 5 or 12 volts, depends of the sensor, and one of the cable there is a typical halotron signal, just like you have seen on the oscilloscope.
What I can suggest, so I will switch the probe sensor for another two signals and show you to our listeners how the signal will look like if I will switch it.
Okay, so I will deactivate the channel 1 is the channel from the camshaft. Right now Marcin is changing probes. Just to show you how to
Yes. Now it's second one.
how to find out the proper cable. Right now Marcin connect the probe to one of the cable. As you can see, this is straight line on that wire. That means this is not the proper signal.
Okay, there will be a third one.
Okay, right now, as you can see, signal has changed also to straight line, but it's higher line. When you
Shut
check
it off.
yes,
And you shut it on.
so right now you have the ground. Here you have the supply. Right, you can check on
Yes,
the
the
oscilloscope
voltage.
the voltage, right? And if we return to the proper wire, we can have the proper signal, as you can see on the oscilloscope. So you need to do the same steps on the second camshaft position sensor and on the crankshaft position sensor to get the proper readings. And once again, we have the crankshaft position sensor on the yellow probe and the camshaft position sensor on the blue probe. Okay, so just remember the shape of the signal, how it looks like, and right now if you compare it to the signal that is on in our manual, that you can see this is the proper cable. Just only a few sentences about the other connection that you can see in the wiring diagram. As you can see, there is more cables to connect, but you just have to remember that not all the cables are necessary to connect to get the TAP works well. I mean, of course, the red cable and the black cable and the blue from
yes, they are mandatory, but there is some optional wirings like the brown one or the gray one. Yes.
That's right, that's right. The brown one from the ignition coil to get the RPM signal, and the gray one from the map sensor to get the load of the engine. If you want to use the fast calibration, just want to use the basic function of the TAP, you don't need to connect brown and gray cable. The TAP will work fine without connection. But if you want to use the more advanced function, there are some distortion in the signal when you use the fast calibration and you do not have connection with the brown and the gray cable. Or if you want to use auto adaptation mode that is integrated.
Or yes, and the next one, or if someone has the skills and is a little bit more advanced in relation to use the 3D dimension map, yes, and the one to set. So it will be necessary to use the ignition coil and the map or TPS sensor be connected.
Yes, that's right, that's right. Especially when you have the signal with the not enough number of teeth, when there can be some other distortion, then we recommend to connect brown and the gray cables.
Yeah, let's switch to AC STAG application and follow the next steps.
That's right. If you open the AC STAG application right now, the tap is not calibrated. It's settings that come from the factory. That's why you can have the no crank synchronization in the errors. But first step you need to do is to check the values in the parameters, some basic parameters. I mean, fuel type, type of the advanced angle you want to change using the absolute value, proportional or map, and some of the values are in the gray, and you cannot change it because right now the tap is not calibrated. It's the settings from the factory. If you made after the auto calibration, you will have access to all the functions.
Exactly. So let's start the calibration now.
Okay, so just to save some time, we try to start the fast calibration, and we will see the final result, what tap will recognize according to the signals. Information about not to change the load of the engine during the auto calibration. Okay. Now the process is in progress. TAP right now, TAP right now is reading the information from the sensors, from the crankshaft position sensor, from the camshaft position sensor, and after a few seconds, few minutes, it will.
What you can predict? What will we need to see there on this rotation?
I would like to see 3 signals here.
Sure.
Sure.
Are you?
Yes, yes, I'm sure. So 3 signals. I would like to see, let's say, 1 from the crankshaft and 2 from the camshaft.
Okay. Not the Santa Claus graph.
No, Santa Claus, no.
No.
But other graphs, yes. But I will not tell you which one because.
So now the autocalibration process is finished, and we can follow the settings and see predictions and see the end results. Will be a Santa Claus graph? Oh no, just just
some
3
blue
signals.
and red lines, right? Okay, so right now what you can see here is the result of the autocalibration. Blue lines, blue graph is a crankshaft position sensor signal, and camshaft 1 and 2 on the red. So you can compare those signals with those one you have seen in the external oscilloscope connected to the sensors. They are very similar. I can say that they're exactly the same.
They are not Santa Claus graph. No.
What you are talking about the Santa
Claus?
Claus?
Because he's coming.
Santa Claus is coming, right. Right, okay.
So what we can do now, I think we should show how the simplest way and the easiest way start to set the line. That's called the line because there is also a map and more complicated, but the line is the simple one. It's fastest and the easiest way.
Okay, so in the parameters, if you want to use map, you need to change from the proportional to map.
Exactly.
And then just change to
2D,
dimension absolute. It's already chosen. So right now the mode is on, map is selected, to the absolute, the CNG like the fuel.
Yes, and meanwhile I will connect the second oscilloscope probe to the output of TAP.
Okay, okay, I understand.
Can you show me what's happening now?
Okay, so right now on the oscilloscope file, as you can see on the screen, we have 2 signals.
Yes. The yellow and the blue, and the yellow is the one is coming from the sensor.
From the sensor, okay.
To the TAP.
To the TAP. When I make the pause, yes, you can compare those signals. It's
and the blue one
right?
is this one which is coming out from the TAP to the petrol ECU.
That's right. Right now you can check that both signals are the same. So the enter of the TAP and the exit of the TAP, we have the same signals, but we haven't changed anything on the map yet. So we need to change some values on the map, and of course we need to switch to gas. As you can see,
gas is on.
Okay, on the left side there is a status of the TAP. It's gas, so it's working on gas. So right now we can change some values on the map.
Yeah, go on.
Please draw the Santa Claus, please.
Santa Claus is coming. He's already in town.
Oh, already in town, okay.
And the rules are like in the Qbox, Qnext and GoFast ECU. If you have a multiple line, you just put the regulation point on it, mark it on the red, and then you can move it up or move it down, of course. And what I can do now, I will move the graph also on idle, that we can see what will happen in the output comparing to inlet of the signals at the oscilloscope. So let it see what is happening with the angle. So TAP is now moving the angle 8 around 9 degrees. Yes. So we can see all confirmation on the gauge here, and you should see on the oscilloscope. Let's run the signal and watch out what is happening here. Thomas, what's happening?
Okay, so right now, as you can see, once again in the yellow probe we have the signal from the sensor, and on the blue probe we have the signal that is sent to the ECU, car
Exactly.
ECU. As you can see, there is a, maybe I will change.
Yes, there is a threshold, and this threshold, this is the reason why petrol ECU is advancing, because he's having a signal from the TAP unit that is moved in the time. It's
That's
just
right.
advanced. Yes, angle, and this angle exactly what we can see is here. This is 9.2 degree.
Degrees.
Yeah,
That's right.
exactly.
So right now we change the ignition point. Right?
Exactly. As on the graph, we should find the place that to move the ignition point to have better efficiency in relation to the pressure in cylinder. And this is the effect what we are doing.
That's right. That's right.
At
So-
the end, I think we should a little bit speak on one functionalities in advanced mode.
Ah, okay.
Yes, because like in this engine, on the inlet valve, there is a camshaft that it's having a variable timing. So during the driving, you can see on this gauge, it will start spinning around from the left to right to -10 to maybe even 20 to -20 degrees. In case you meet some issues with the jerkings or other unstable working engine conditions, you can run on the fast correction for this cam. It will help to resolve the issue with the jerkings, yes. And then you can also have an influence on the algorithm. You can add or reduce these algorithm factors that the end results of jerkings to reduce it totally and forget about any issues. It's working also with the first cam and the second cam. In case you are meet the engine with variable cams, not only on inlet like in this engine, but also on the exhaust cam, so you have an optionality to use the corrections for both cams to resolve any issues in relation to variable cams and variable cammings.
Okay, and I have one more information, because we had also a question about this. Sometimes when you do the auto-calibration, and after auto-calibration, TAP will read all the parameters and also the RPM parameter, but if RPM parameter is not the same, like you can see on the dashboard in the car or in OBD reader, or external scanner connected to OBD. Sometimes after the auto-calibration, the RPM value is 2 times higher or 3 times higher.
Or even lower.
Or
Because
lower,
can be
yes.
lower.
Lower.
Yeah.
So you can check one thing. Use in the RPM range, RPM divisor parameter. So if you change it to, for example, 2 or 3, and then you start once again the auto-calibration, you will find out that the RPM reading values are the same like you have
Like
in the
it
dashboard
should be,
of the
yes,
car.
like the real values. That's the factor that you can use it to fix it, yes, fix it, the readings. That's
That's
very
right, that's right.
important.
So just remember, if you connect TAP and you don't have the values right here on the right side in the monitor window, you need to start first auto-calibration. After
Exactly.
auto-calibration, system will show you the values.
Exactly. So, guys, we want to thank you for attention for this webinar. Please bear in mind that this one webinar is the last one in this year. So in this case, we want to wish you a good year. Stay healthy. In case of any questions, do not hesitate, please, to ask using email or WhatsApp communication or other facilities in case of YouTube or Facebook. So again, have a nice next year. Take care and
Yes.
see you guys.
See you soon. Bye.
Thank you again.